All right, it has a vertical stretch. That's the A coefficient, which affects the amplitude. It's also a reflection across the x-axis, yes. B is 1/4, which seems like a horizontal shrink, but it happens in the opposite way you'd think it would. It's a stretch. If you calculate the period based on 1/4, it's 2 pi over 1/4, which turns into 8 pi. Definitely a horizontal stretch. It's not right 2 pi, it's not left 2 pi, it's right 2 pi, and it's up 5. Because it's sine, the first point starts on the midline. And that's even if the thing's transformed and moved around, its sine always starts on the midline. Cosine starts on the max or min. If you do graph this in your calculator, I'm going to graph both functions, the original and the transform graph. You need to set your window big enough so that it can accommodate all those transformations. It's been stretched out by 4, so I need to increase my x max. I changed it to 8 pi, the period. And the x scale, you want to change that to either like pi over 2 or pi over 4. I guess it depends on what your period is. The default might be just whatever the quarter period is, which in this case would be 2 pi. So maybe I'll change that. 2 second pi. Enter. All right, so that's going to make my tick marks appear every 2 pi. So I can't even see my tick marks, but I kind of see that one. And that probably is 2 pi. So 2 pi, 4 pi, 6 pi, 8 pi. Yeah, that's one period. Now, it's probably not worth using your calculator to do this one, but it does give you the ability to visually estimate some of these things. Yes, it's definitely been vertically stretched. Yes, it's definitely been horizontally stretched. The phase shift, I can see there is one because the red line is no longer starting at the midline, which a phase shift will do that. Yeah, it looks like it turned into cosine, right? But no, it's because it's been shifted to the left or right. So see, it's shifted to the right. So I guess 2 pi, this is my starting point. Oh, you can't even see my cursor. But it's at the, the first tick mark. Right in the middle. That's 2 pi, so that's the starting point. And yeah, this one goes down because it's a -3. All right, yes. And some of these others you can obviously identify. Yeah, it's been shifted up 5. The midline's at 5. I'm going to go back to my calculator. I'm actually not going to delete this one, but I am going to turn it off. Is that how I do it? And I'll save it for later so I don't have to retype this thing. If I have another one that has like so many transformations, I'll just edit that one. All right, so now I'm going to go back to this one and just type in cosine 2x. Let's see, cosine 2x. All right, I want to make sure I'm in the right mode, which is radians. If you're switching modes, don't just highlight it and then second quit. That doesn't do it. You got to hit enter. So if I want to switch to degrees, I have to hit enter. Now it's switched, but I want radians. So let me hit enter again just to make sure. All right, graph. All right, for this one, I'm gonna have to change my window again to match this problem. Looks like it goes negative pi to positive pi. So negative pi, and then down, and then just pi. Now I don't have to delete that. I can just override it. For my x scale, I guess I'll mimic theirs. Usually I would choose pi over 4, but for whatever reason, I'll just try to really mimic theirs. Their tick mark is at pi over 2. Pi divided by 2. And my y's are fine, I guess. Let me mimic theirs exactly. Their x max, their y max is 2. All right, there we go. Let me hit enter to make sure it graph. So we're just seeing if this is true, if this graph is actually cosine 2x. It looks like it's true. So the tick mark really helps me there, setting that tick mark. If I just leave it as 1, which is the default, then the tick marks don't line up with their tick marks. So I can't really tell if it's the same graph or not. So yeah, that's one of the main points I want to get across is set those tick marks to some version of pi, either pi over 12 or pi over 4. Usually I use the quarter period, which would be pi over 4 in this case, since the period's pi. Okay, I probably will not type this one in, but I don't know, you probably should. Yeah, in this one, the midline was 3. You started out graphing it correctly, and then you went up 4 in the amplitude from there, which you should have drawn a tick mark, and then you should have gone down 4 from there. And then the graph would have been shaped like, let's see, what are the quarter periods? Pi over 4, so that's a quarter period, so sometimes even dash those in. But it would have gone, since cosine high, middle, low, middle, high. That's too bad because you made one mistake, but it cost 3 points because those teachers are mean. And even without it, well, with a calculator, if you want to check your graph, obviously just punch it in your calculator. But without a calculator, you can also just plug some points in. So say you've got this point on your graph, which we know is not correct. We could detect it by plugging in pi over 2, this x coordinate, in for x. So let's see, cosine of, let's see, 2 times pi over 2 is pi. And cosine of pi is -1. 4 times -1 is -4, -3. It should be at -7, so we can see this point isn't correct. So it should be down here at -7. And I see in this one, they're describing the graph. They're giving you a max and a min and some other information and a period. There are some formulas that convert the min and the max into the midline and the period. And those two formulas are very similar. One of them is subtract, one of them is add. Let's see, the midline would be the average of the max and the min. The midline, the midline would be the average of the max and the min. I usually don't memorize those equations. I just draw it out. So maximum of 23 and a minimum of 7. Then I can visually see, oh yeah, to get the middle, I'll take the average. And once I have the midline, what I'll usually do is just subtract the max from that new found midline. Or you can memorize those equations. So once you have your midline and your amplitude, and then you change your period into b using this equation, you've got your answer. To check it, you can either plug in some points, which is kind of tough. Let's see. Yeah, I guess that's only to validate our graph. Okay, so we're also asked to graph this thing. So I won't go into it, but I'm just making the suggestion. Once you get your graph laid out, you can plug this in your calculator and just see if it matches your graph. Or just start by plugging it in your calculator. In this one, your quarter period, see what was your period? Period was 4. So the quarter period is going to be 1. So that means in your calculator, you'd want to do your x scale to be 1. You can see in my calculator settings currently it's at 1. And that will make your tick marks on the calculator graph occur at convenient quarter period intervals where your key points should be. So here they're giving us a graph and asking us to figure out which equation goes with it. You could plug each of these into your calculator, but that would take time. The easier way is just to pick a point on the graph. That's the easiest point, and plug that x value into each of these ones. It kind of requires you to be a little bit familiar with your unit circle. So I'll plug it into this one. If I plug in 0, I get sine of 0. So that's where you got to know your unit circle. 0 degrees is right there. Sine of 0 is the y coordinate, which is 0. So this whole thing turns into 0, so it's -2. So this one gives me a y coordinate of -2 at 0. So that's not that point. If I plug this in, it's going to be cosine of 10, which I know right away that's not going to work. When I'm plugging in one of my key points, the cosine or the sine should always turn into 0 or 1 or -1. And that's just not going to happen with cosine of 10, so I know that's out. And I know the same reason that one's out. So that leaves me with this one. Cosine of 0 is 1, 3 times 1, and so on. It gives me that point. Now, if you're not using your calculator, you would have to like maybe calculate the midline. They all have a midline of -2, so that didn't help. It looks like they all have an amplitude of 3. It's definitely a cosine because it's starting at the max. And let's see, this one has a phase shift of 2, so that leaves you with that one. All right, so I'll probably not use the calculator for this one just because it's not the quickest. That last one seemed to go pretty well just looking at the midline, but they all have a midline of -3. There's no phase shift because this graph starts in the midline, so those are out. And it's a sine function because it starts at the midline. Cosine would have started at the max. To verify, you could plug in a point, so I could plug in 0 and get -3, which is that point. If I really wanted to go for it, I could plug in even another point like pi over 8. So 4 times sine of 4 times pi over 8 is sine of pi over 2. I know I'm going quick, but we kind of should be able to do pi over 2 without even really thinking about it. Pi over 2 is up there. Sine is y. So in that case, this must be 1. 4 times 1 minus 3.